Today, we're sharing this special episode of On the Mind, the official podcast from the Weill Cornell Medicine Department of Psychiatry. This conversation features Dr. Francis Lee. We discuss adolescent mental health and the risk and resilience during teenage development.
Hello, and welcome to On the Mind, the official podcast of the Weill Cornell Medicine Department of Psychiatry. I'm your host, Dr. Daniel Knuffelmacher. In each episode, I speak with experts in various aspects of psychiatry, psychotherapy, neuroscientific research, and other important topics on the mind. Our topic today is the neuroscience of the developing brain. As I discussed in an earlier episode focused on youth anxiety with Dr. Angela Chu, we're in the midst of a youth mental health crisis. Currently, 10.6% of youth in this country cope with severe depression, a number that increases to 14.5% among adolescents of color. Many psychiatric conditions emerging in childhood and adolescence progress into adulthood, especially when they go untreated. In fact, 3/4 of all psychiatric disorders emerge by young adulthood, while it typically takes up to 7 to 8 years before these symptoms come to the attention of a clinician. Ongoing neuroscientific research has shown that the brain is tremendously vulnerable to stressors during critical stages of development, periods that hold the potential for enormous resilience. Today, we will take a deeper look into the brain during childhood and adolescence. We'll explore why many psychiatric conditions emerge during this sensitive period, shed light on the significant risks and great potential that exists within the developing brain, and discuss how recent neuroscientific discoveries are leading to new, promising treatments specifically optimized for adolescents. I'm pleased to welcome a special guest to the podcast today, Dr. Francis Lee. Dr. Lee is a neuroscientist and psychiatrist who has done pioneering work studying the molecular basis of mood and anxiety disorders. His research has focused on understanding why so many disorders emerge during the transition from childhood to adolescence. He is professor of psychiatry and also the chair of the Department of Psychiatry here at Weill Cornell. And most importantly to me, he's been a thoughtful leader and a loyal supporter of this podcast. Francis, it's great to have you here to discuss your research.
Thank you, Daniel. It's great to be here.
Well, we tried to get you on for a while, and my sense is you may have a few other things on your plate, but I'm going to jump right in because we have a lot to discuss. So I want to begin by asking you, how'd you become a neuroscientist and a psychiatrist? And I guess specifically, how did you come to focus on the neurobiology of anxiety and mood disorders in the developing brain?
I was very lucky. During high school, I got a summer job at the local college in a neuroscience lab. It just happened that that local college was Princeton University. I was able to work in the lab of Dr. Bart Hobel, where they were studying how neurotransmitters changed during behavior. Again, this is in the 1980s. The fact that I, as a high school student, could be in a cutting edge neuroscience lab was a stroke of dumb luck. And I loved it, not just because it was sort of cool to be able to see neurotransmitters go up and down in an awake, freely moving animal, but that I was introduced to an entirely new field of investigation of neuroscience and emotions. And I think what was critical was that it occurred when my prefrontal cortex as an adolescent and young adult was able to receive all this new information and was able to incorporate it and see it in a different way that I would have if I was younger or older. And I was very fortunate to continue to work in that lab for the next 4 years when I went to college. And at the end, my identity as a neuroscientist was sort of cemented. Fast forward, I went to medical school and I was not sure what field I wanted to go in. But during my psychiatry rotation, I was in an anxiety and mood disorder clinic. And I was interacting with adolescents and young adults. And what I was struck by was that in this field of psychiatry, we had multiple modalities of how to treat the patient. We had psychotherapy, such as cognitive behavioral therapy. We had medications. We even had neuromodulation in the form of electroconvulsive therapy. So I was, I think, a very optimistic medical student. I go, this field has everything. It's got three different ways to treat a disorder. And I was thrilled that I was able to basically match here at Weill Cornell to do my residency and eventually started my lab, which again focused, as you said, on the neurobiology of anxiety and mood disorders.
Wow. And it's funny because I don't know if you remember this, but there's actually a connection between you and me here, which is that I was also a teenager in Princeton. And one of my best friends in high school was Brett Hobel, who was Bart Hobel's son. I remember going into with Brett the freezer in their basement and opening up the door and finding frozen rat heads as a teenager, which I can tell you my prefrontal cortex at that age was not as developed as yours. But this brings us to what our topic at hand is, and that's these critical periods of development that, as you've shown in your work and has been demonstrated elsewhere, are linked to the emergence of psychiatric disorders. So, can you explain what's going on during these critical times in the growth of children and adolescents?
So humans as a species has probably the longest period of development from childhood to adulthood. It spans 2 decades essentially, which is longer than any other species we know of. And what's amazing is that during that period of time, there's tremendous plasticity, and it's almost like a cascade of developmental events. And during the cascade between the transition from childhood to adolescence, things can go awry. I think this is one of the biggest questions we will face in the next decade of what is it about periods of heightened plasticity that also lead to periods of heightened risk. And there's something about as the brain is rewiring itself during this period of time, especially the emotional circuits seem to be quite vulnerable to predisposition to anxiety disorders as well as depression.
Now, you mentioned circuits, and there's all of these changes occurring. I think it might be helpful for us to focus on the critical regions of the brain. And if you could describe their functions, their significance, of course, their names, and what's going on with these regions during that time.
So there are three major brain regions that are very much involved in emotional regulation. The one that develops first is the amygdala. It is at the base of the brain and essentially is monitoring for threats as well as rewards. And it is very active during infancy and during childhood. The one that is most famous is the prefrontal cortex, which is in the higher cortical regions, which is mainly involved in making decisions and sort of assessing multiple contingencies as it's receiving all this input. So it's much more of a cognitive reappraisal or cognitive center. That does not develop until the age of 25 fully. So during this period of infancy to adulthood, we have an amygdala that is essentially teaching the infant and child brain what the world is like. Interesting enough, it is actually teaching the prefrontal cortex what is going on. And then at some point in the transition from childhood to adolescence to young adulthood, the prefrontal cortex will then wire up with the amygdala and then start taking control of it. And this is what I think has been most well known. What has also recently been found is another brain region called the hippocampus, which we normally think of as in terms of spatial navigation, seems to also wire up during this period of time, especially during adolescence. And I can discuss it more later, but essentially, as long as we keep these three brain regions in our mind, I think we'll have a greater sense of how the brain is developing from the bottom up initially and then from the top down.
So, keeping that in mind, these three key regions, tell us about what happens both in normal development during this time and then what may go awry when an adolescent develops depression or anxiety.
Most of the research has shown that if there is any type of early life stress, the type of stresses I wanted to say are there's stresses related to deprivation, like separation of caregiver from child or from some type of threat, such as some type of physical or psychological abuse that occurs during childhood, actually leads to, paradoxically, an acceleration of the wiring up of these three circuits. They're seeing three brain regions together. It's almost as if the brain is adapting to potentially a difficult environment and is growing up quicker. So, in many ways, you would think that's a good thing that your brain is developing faster. But what we've learned, and this is mainly from cognitive neuroscientists who've been doing functional brain imaging in humans with parallel psychological testing, is that while you gain heightened emotional regulation a little bit earlier, you pay a price that your brain skipped a number of steps. It's sort of like skipping grades in school. It's great for certain things, but then you don't socialize so well later on in high school or something like that. This is, I think, what happens to the developing brain. And it's possible that stress leads to these types of aberrant wiring up. But I think the major caveat, and this is something that the field in psychology as well as developmental neuroscience has had to contend with, is there's enormous heterogeneity, that these stressors and events are probabilistic, but they're not deterministic. And I think one way to say it is we don't know why certain stressors affect certain people more than others. The other way to flip it on its head is that actually, why are certain individuals more resilient in terms of being able to withstand the stresses and basically get back on the right track of the developmental cascades that are needed to basically wire up correctly by the age of 25.
So it's a nature versus nurture question. There's some innate qualities, and then these stressors that these two things together can lead to illness.
But again, I think this is going to be the major question for the next decade, is can we be more precise to know exactly what circuits and what connectivity abnormalities occur, and can we intervene sooner than later and not wait 7 to 8 years as is current practice now in terms of treatment.
So we talked there about this, which is very interesting, kind of growing up too early metaphor, that this is a rapid maturation that happens under these stressful circumstances. Tell us a bit more about the normal process and at what ages those are happening and what that looks like.
So up until the age of 9 to 10, the amygdala is slowly connecting with the hippocampus as well as the prefrontal cortex. Most of the research this is based on is both human neuroimaging work as well as rodent anatomical tract tracing work. But that ultimately, around that time, in that transition from childhood to adolescence, the prefrontal cortex now starts to send connections back down to the amygdala as well as the hippocampus. As a nerdy neuroscientist, it's an extraordinarily beautiful dance. Essentially, you have bottom up connections that essentially instruct the higher cortical regions and the hippocampus to then send connections back down and wire up in a very exquisite way, which we still do not know the exact details of. Then at the end, you have a finely tuned emotional circuit that can basically tamp down an overreactive amygdala or something. Just to give you an example, every day our amygdalas are going off because, as I was noting, that I might have missed something on my calendar, my amygdala went off. But within a minute, I realized that I didn't miss the meeting, and I was able to regulate that sort of amygdala signal. And I think this is something that doesn't occur that well in infants and children. But what research has shown is that the presence of a parent in particular buffers that. And essentially, during this period of, especially during childhood, you have external forces that are able to basically provide scaffolding for these types of reactions to the external world.
And just so I'm clear, you're describing an amygdala up process, and that is connecting to which region?
To both the hippocampus and the prefrontal cortex. Most of the research has been in the exquisite sort of connection with the prefrontal cortex. But I think the exquisite dance that occurs is during adolescence, the parent can no longer serve as that buffer. The goal and the job of an adolescent is to go out into the world and make risky decisions and do other things and not to rely upon this sort of built-in buffer that was there for the first decade of life.
So this is a period of increased risk taking. There's lots of impulsivity, reward seeking. What is going on at that period where that's happening the most? Which stage?
That is occurring during the transition from childhood to adolescence, and where now the prefrontal cortex and the hippocampus are just beginning to come online, but they're not as efficient as it is currently. So you have a slightly inefficient prefrontal cortex trying to exert top-down control, a hippocampus that is also wiring up. But again, nature set this up so that the adolescent would actually start learning more about the world and to explore and try new things that it would not have done before. This is not a disorder in any way. This is actually perfectly tuned to what the job of an adolescent has to do. If you just think about what an 11-year-old can do versus what an 18-year-old can do in terms of cognitive function and independent activities, that is what has to happen during this sort of sensitive period of cognitive development.
So I'm wondering if you can help us think about the neurobiological correlates that are underlying something that we certainly see in our society with, as I mentioned in the introduction, increased amount of anxiety and depression among, for instance, children of color.
That's a very good question, Daniel. Actually, there's a lot of research that has already been done studying early life adversity, in particular, as you mentioned, poverty and other social determinants of health on the maturing brain. While there's no consensus now which brain circuit or which brain regions are affected, in general, it is well established that neurodevelopmental trajectories of brain development are altered by these external environmental components, which produce threat deprivation as well as uncertainty in the environment. What's much more difficult to pin down is what are the resilience or protective factors that would reroute these adverse neurodevelopmental trajectories. And I wanted to just highlight a very interesting study that came out last year from Dr. Kate McLaughlin at the University of Oregon. She was using a database of the largest longitudinal study of youth, 11,000, that is going on right now in 17 states. And she was correlating lower family income with not only with brain volumes, but also with internalizing symptoms such as anxiety or depression. And what she found was that lower family income correlated with lower hippocampal volume and increased anxiety and depressive symptoms. But fascinatingly enough, those states that had robust anti-poverty programs, these disparities in brain structure and symptoms were reversed by 1/3. And it really suggests that these type of macroeconomic sort of interventions might have an effect.
Well, that's really interesting and actually quite hopeful, just seeing that these social programs and then, of course, interventions, if we can get people access to the care they need, because the brain at this period has so much plasticity, that there's actually hope for kind of reversing some of these generational trends.
Yes. Among my colleagues, we always say that while there is increased risk of these types of external stressors on the developing brain, it also is probably an amazing opportunity to intervene during this heightened time of plasticity.
Well, once again, thinking about this heightened period of plasticity, I want to turn to something else that certainly was on my mind as a parent with my kids growing up, which is the impact of smartphones and social media. Thinking about the brain and what you know about it, what role do you think these devices had on the mental health of so many adolescents?
Well, first of all, the, the human brain evolved in a period of time where there was no internet and no smartphones. So you have to imagine a world where basically you were in a nuclear family or extended family where you were able to, as a child or an adolescent, interact with elders, peers, and play outside and do various things. And now what you're describing is a different type of experience where it is no longer going outside into a playground. It's actually going inside or staying inside and interacting with a digital device. I think that is categorically a different type of experience of growing up. And this is work pioneered by Jonathan Haidt at New York University, that there is a sort of switch from playground based childhood to phone based childhood, which I think we don't know what it is doing to the developing brain. But there is data out there that around 2010, 2011, there was a technological advance. The iPhone 4 came out, and there was a front facing camera for the first time. And around that time, Instagram, a year later or so, was acquired by Facebook. And around 2012, 2013, is when we see a small uptick in the incidences of anxiety and other mood disorders in adolescents. It's a correlation, but it also sort of harkens like the technology that has been emerging in our society has led to a different type of social interaction where you have cohorts of adolescents that only meet on digital platforms. And you have to go to those platforms and interact. And if you are not part of it, you miss out on multiple interactions. So it is a double edged sword, and it expands your social network, but it also provides opportunities for also social isolation and physical isolation.
It's pretty profound. And I think about my own kids who grew up during that period and definitely grappled with that and continue to. It's all during this period of development where, as we've discussed, there's increased risk for the emergence of psychiatric disorders. At the same time, you've described it already as a period of great neuroplasticity, amazing change in the brain. And with so much potential for positive change, does this period also present opportunities for treatments that can help when these processes that you described with stressors, et cetera, are maybe leading towards a disorder?
Yes, I think that is the great hope of how we can leverage techno- neuroscientific advances that we could possibly have greater insights into the developing brain and figure out new ways and modify the current treatments we have in some way that is optimized for especially the developmental period of adolescence when you now have a developing hippocampus and a developing prefrontal cortex. Is there something that can be used during this period of time? And I'd just like to sort of tell you about some work that has happened here in our department in collaboration in my lab and others. That several years ago, we actually found out that the hippocampus, contrary to what is expected, is actually not pruning, but is actually expanding and hyperconnecting during an adolescent period in rodents with the amygdala as well as with the prefrontal cortex. And that it seems to be quite involved in regulating fear responses during this period of time, much more so than later on. And we found that actually a very specific type of learning specifically activates the hippocampus. And I'll explain it to you in some details. Normally, when there is a fear response to a threat, the normal way to diminish that fear is to play that cue or threat over and over again. And then the prefrontal cortex learns that this previously dangerous cue is no longer dangerous. This is the essence of the learning theory of exposure treatment, which is embedded within cognitive behavioral therapy. And so that has always been thought to be the mainstay of how you treat anxiety disorders as well as depression. But now you have a developing brain where the prefrontal cortex might not be fully online. What we found is that during adolescence, the hippocampus is fully online. And there, if you give them cues that denote safety, the hippocampus seems to light up. And we've done this both in rodent models, but also with my colleague at Yale University, Dylan G. She's been able to do parallel studies in humans showing that safety signal learning preferentially activates the hippocampus and will also suppress fear responses. And so I think this is an interesting insight into what is possible. For example, embedding safety learning cues within the distant future into some type of modules that would be involved in treating adolescents with anxiety disorders or depression would be one option. There's many steps to go, but this, I think, is one where we find something very unique about the adolescent brain and then try to develop either psychotherapy modules or even in the future, hopefully, some other types of treatments that can target this sort of very transient type of situation within the developing brain.
So, just to clarify, you described as it is an exposure therapy, which we've talked about on this podcast before, where there's some sort of stimulus or something that is evoking anxiety. And with continued graded exposure to that, there can be what we call extinction of that response of anxiety. You're pointing to something novel where there's this safety signal that at this critical stage of development during adolescence where you've discovered that the hippocampus is playing a role that before your discovery of this it wasn't quite as appreciated, that during this time, using a safety signal can actually work better for adolescents in terms of extinguishing anxiety. I'm curious, what does that look like? What is the safety signal? You mentioned Dylan G's work, and I imagine it might have been in mice, but I want to hear about it in humans. Tell us what a safety signal would look like and how that would be used to improve somebody's anxiety.
So in Dylan G's study, she actually used two different colored squares, where one square denoted that they were going to hear a loud noise, like a blue square, and a yellow square denoted that there was not going to be any loud noise for a minute. But I think in the real world, just to give you an example, let's say that you have someone that is afraid of snakes. And then the type of exposure based treatment would be to show the patient pictures of snakes and maybe even go to a zoo and look at snakes or something to do some type of graded exposure to that. Again, most patients who are afraid of snakes say, I don't think I want to go to the zoo. I'd rather just not do any of this. But if they had some type of lucky charm or some memory of some safe environment that they thought of, then before they did their exposures with their therapist, this would be one way of incorporating safety signals. One way to think about this is, as we noted before, our amygdala is always ready to raise the red flag that there's something dangerous in the environment. And that you can imagine that as you are about to begin a session to do exposures, this would be very difficult to do. But if you can add a safety signal just before the exposures, you're basically giving the brain a timeout, just as saying, giving it a pause before the amygdala starts going off. And this pause of letting the hippocampus catch up to suppress the prefrontal cortex is one way a safety signal might help accelerate the learning that this previously dangerous cue is no longer dangerous.
Now, that's especially effective with adolescents. Do you see that also still working in a fully developed adults who have a prefrontal cortex that is already dominant?
Yes, so safety signals work also in adults. Again, these are all very sort of controlled settings, but the hope is that we can test this more fully in larger clinical populations. The initial evidence is that it's a little bit more effective than traditional exposures during adolescence. And I think that is the key, that we think that this might provide an additional tool, not the only tool to do this type of treatment. Again, you have to remember that cognitive behavioral therapy is extraordinarily effective for a certain group of people, but that for both adults and adolescents, there's also a group that don't respond so well. And we always want to have additional options. And I think that's the way to think about this, and especially for adolescents, because this is a sensitive period of hyperplasticity. If we can treat during this period of time, we will probably have a better outcome, hopefully, in the future.
Can you speak to how this will translate into treatments specifically targeted for adolescents?
We've been thinking about this a long time because it's very difficult to do clinical trials where you try to put in a safety signal in a one-to-one interaction between a therapist and a patient these days. These are typical clinical trials that are enormously expensive and time intensive. But recently, in the last several years, with the rise of mental health apps, it's possible to do these types of trials using digital tools. So our department has taken the lead by developing a set of digital tools that incorporate CBT skills, specifically for youth with anxiety disorders. And we think this is the perfect platform to do these types of investigations, where we will add safety signal learning modules alongside the exposure based modules and see whether or not they will, first of all, be more effective in diminishing fear, but also have greater engagement, allowing them to practice more these types of skills by providing, as I said before, this brief pause of allowing their amygdala to calm down before they begin their skills training, that they will actually want to do this more often.
Well, that's exciting. And it's on the very platform that early on we said a lot of adolescents are prone to use, which makes it probably very accessible and easy for adolescents. I want to ask you two more questions. And the first is, knowing that you have been investigating the inner workings of the adolescent brain, I'm wondering if you could speak about the role of parents and any specific considerations, advice, things that should be thought about by parents who are raising adolescents?
I think the best way to think about parents, especially during what we believe to be a period where there is a youth mental health crisis, they are the untapped workforce that we need. We need parents to be involved in a way that they've never been involved before. And I would say, in sort of a slightly counterintuitive way, especially for those parents who have kids with anxiety issues, your natural response is to protect, do everything to help with diminishing the symptoms of anxiety. But as you know, the core principles of cognitive behavioral therapy are to face your fears. So the goal of parents is to be the scaffold that helps instill, for example, bravery in the kids so that if they're afraid of going to school, the option is not to stay home, but is to help them go to school and to do everything to facilitate them to be the sort of engaged social creature that all adolescents should be and in all new environments they need to explore. And you use that as the organizing framework of how you think about how to be good parents. And we're actually developing a digital behavioral skills app that we're actually going to target for parents because we think that this is actually something that will be another way that we might not expect children to know all the ways of using CBT skills, but parents can now use it in a way to help inform not only their thinking about how to think about their kids, but also to build resilience within potentially periods of time where the brain is particularly plastic.
And do you think that includes safety signaling, like a parent knowing that that kid going to school has that special object that always makes them feel safe that they can hold with them when they go to school, or thinking about how to apply that as a parent?
We were just discussing it this week, Daniel. This is exactly what we're thinking, that for the self-guided CBT skills app, that we would have safety signals learning embedded, but also for the parental version, where basically we would also want them to create safety signals. And the safety signal is not to promote an avoidance of what's supposed to happen. It's to actually facilitate being able to do the exposure-based exercises, going to hopefully do that type of cognitive switch within their prefrontal cortex or their hippocampus, that this is previously dangerous, but no longer as dangerous as we previously thought.
That's fascinating. Well, one last question for you. And this is as a neuroscientist, as the chair of a department of psychiatry. What are developments in our field, including ones that you're working on, that you feel are going to hold the most promise in the future of psychiatry, in the future of helping people with psychiatric disorders?
I've been thinking about this a lot every day, actually, because as you know, our clinical services are being stretched as we speak. I would say that the hope has always been that we could leverage neuroscience and technology during this sort of inflection point we have, where these discoveries are being made, and to improve the treatments that we have for our patients. I would say that what we need to do, which is to begin to think in new and creative ways, because we cannot do what we've always been doing in order to contend with this. And just to give you an example, for many decades, we believed that it was so important for us to see our patients in person and to really get the most effective treatment. And the pandemic has shown us that for mild to moderate cases, we are able to use telepsychiatry very effectively. Now, what I would also challenge our field to think about is, do we need to see them as often, and that can we use whatever a variety of augmentative digital tools in between to basically extend the reach of all behavioral health providers. And I think this gets to something else, that we might have very good treatments. Like, we will hopefully in the next 2 years figure out how to incorporate safety signals into some new forms of exposure based therapy. But that ultimately, how are we going to get this to everyone in our society? And I think that this is something I think about and keeps me up at night, in terms of we need to do things that will also be able to expand access to these treatments. And this is where it is not a binary sort of thing, but that ultimately the incorporation of these types of digital platforms might be one way with which we can not only push the envelope of what we were doing in translational neuroscience, but also to be able to provide the best evidence-based care to as many people as possible.
Well, thank you for sharing your vision of the future and the work that we have to do to increase access in this field, which certainly is of paramount importance. Francis, I just want to say I'm so glad you were able to join me today to discuss your work. I know I learned a lot about the neurobiology of the developing brain just from speaking with you today, and you really helped make sense of these complex and consequential processes that emerge within the brain during adolescence. The important discoveries that have been made by you and your colleagues, it's exciting to hear about how they can be translated into effective treatments for so many adolescents who need them. So I think people should really be keeping an eye out for the development of the apps that you're describing. What would be the name that people should be paying attention to as they're looking for this?
The app is actually called Maya, and it was a project that was led by Dr. Avital Falk. And we started this project because we believed that we could create a digital app that would serve as a flexible research platform to build and test next generation versions of CBT that were optimized for the developing brain. And as an example, based on the findings of the effectiveness of safety signal learning in mice and humans in reducing fear responses, a project that I mentioned before that was led by Dr. Heidi Meyer when she was in my lab, we are now embarking on incorporating and testing safety signal learning in this CBT Skills app. By the way, we've made a basic version of Maya, the CBT Skills app, available for free on the Apple Store. While it's not intended to be a replacement for therapy, we want to provide it to anyone who wants to learn and practice CBT skills. In this way, we hope to diminish the hurdles to learn about CBT skills. And ironically, by providing these skills in a user-friendly format through smartphones, we are also trying to take advantage of a familiar channel that youth use to receive and interact with new information.
So those same cell phones that we were demonizing before, they may be used as agents of good as well.
Exactly. We are very encouraged with the possibility that we can now use this digital platform that had previously been potentially creating mental health issues with one that would actually help promote mental health well-being as well as resilience.
Well, there you have it. So it's available right now on another thing I just learned on the Apple App Store. And this is a next generation mobile app designed to provide optimized treatment for adolescents and hopefully over time increase access to care, which is what you pointed out is of paramount importance. So thank you. Thank you for all your important work and for coming on the podcast today.
Thank you so much.
And thank you to all who listened to this episode of On the Mind, the official podcast of the Weill Cornell Medicine Department of Psychiatry. Our podcast is available on all major audio streaming platforms, including Spotify, Apple Podcasts, and iHeartRadio. If you like what you heard today, please tell your friends, give us a rating, and subscribe so you can stay up to date with all of our latest episodes. We'll be back soon with another episode.
We're so glad you joined us for this special episode of Kids Healthcast, which features world-class clinical and research physicians covering everything from your child's allergies to zinc levels. Please remember to download, subscribe, rate, and review Kids Healthcast on Apple Podcasts, Spotify, Pandora, and Google Podcast.
Back to Health is your source for the latest in health, wellness, and medical care for the whole family. Our team of world-renowned physicians at Weill Cornell Medicine are having in-depth conversations covering trending health topics, wellness tips, and medical breakthroughs. With the spotlight on our collaborative approach to patient care, this series will present cutting-edge treatments, innovative therapies, as well as real-life stories that will answer common questions for both patients and their caregivers. Subscribe wherever you listen to podcasts. Also, don't forget to rate us 5 stars.
All information contained in this podcast is intended for informational and educational purposes. The information is not intended nor suited to be a replacement or substitute for professional medical treatment or for professional medical advice relative to a specific medical question or condition. We urge you to always seek the advice of your physician or medical professional with respect to your medical condition or questions. Weill Cornell Medicine makes no warranty, guarantee, or representation as to the accuracy or sufficiency of the information featured in this podcast, and any reliance on such information is done at your own risk. Participants may have consulting, equity, board board membership, or other relationships with pharmaceutical, biotech, or device companies unrelated to their role in this podcast. No payments have been made by any company to endorse any treatments, devices, or procedures, and Weill Cornell Medicine does not endorse, approve, or recommend any product, service, or entity mentioned in this podcast. Opinions expressed in this podcast are those of the speaker and do not represent the perspectives of Weill Cornell Medicine as an institution.